Alright, good day. This is Aaron Islas here back again with CSE212, the interview questions for week 4. For this week, it is 2 questions requiring the request of how do we implement stacks using a linked list. And so basically how that works is that a stack will follow LIFO, which is the last in, first out method we learned a little bit ago. When we use the head of the linked list as the top, and then all operations that we will do happen at the same head, and that way we will insert the new elements at the head and remove from the head. And so basically what that will look like is with our operations, for example, push, that's when we insert a new node at the head, and the time complexity to that is constant because it's always just one operation that's at the front. Similar to doing pop, which is removing the node at the head, and that time complexity is also constant because it's just again one operation at the front. For get top, that one is so that we can access the data in the head node, and the time complexity is also constant because we're just directly accessing the head, as what get top means. For is empty, that operation is to check if the head is null, and the time complexity is again just constant 0 to 1, just one comparison because we're only looking for the one position. And in question number 2, it's asking to do queue implementation using a linked list. And how that usually works is that a queue follows FIFO, so first in, first out. And that's when we will use the head for removing elements and the tail for adding elements. And then this way you remove from the front and add to the back just like a real queue. And so basically what that will look like is we'll use the operation called enqueue or onqueue, and that inserts a new node at the tail. The time complexity for that is also constant because it will just insert at the tail in one operation. When we dequeue, that will remove the node at the head, and the time complexity for that is also constant. Removing from the head is just one operation. Now using operation called size, that will return the count of nodes tracked with a size variable. And again, that's just going to be a time complexity of constant. It will just return the stored size variable. For is empty, that operation, it will check if the head is null, similar to what we looked at in the first question, and the time complexity on that is just constant as well because we're only, again, just comparing the one. And basically, like, the key takeaway is that with both structures in mind, both when we are implemented well with linked lists, they work really well. They're efficient because every critical operation happens at the head or the tail, and that avoids costly searching through the entire structure, which is why we have the same constant time complexity across every operation that we had. I think that should conclude all the questions for this week. Thank you again.